Hi, how are we doing? Yeah, well, that's good news, Rachel. Rachel already sharing that the AQA 2018 exams and the examiners' reports are up. So I think that's obviously they've chosen to let out all the 2018 exams up from the 1st of May. So that's great news. So today I'm going to do the feedback from the last question that I asked, which is all about dynamos and generators. So this is an example of a dynamo, in fact, and a alternator, which is sometimes called generators, are slightly different. They've got a very similar, something's very similar, something's different. But I asked you about the design and the output, and then I asked you, if you're an A-level student, what consideration would you need to make if you wanted to smooth that output. Now, once again, Rachel and Harriet's really, really strong. Harriet's fantastic response this time, gets the kind of nod. Rachel's was excellent as well, although the bit about energy at the start you didn't really need in this kind of question. I have an apology to both those young ladies because I missed the fact that they did say alternating current in their answer last time, so well done to them. I'm just going to do the feedback this time. I'm not going to give you a new daily exam question because I know that I can't be live tomorrow because it's parents' evening, and I think I'm going to give it a little bit of a rest until maybe until a couple of weeks' time, where I might come back with this or a different format. But I have got an idea for next week, so stay tuned for from Tuesday on next week, because yes, it is a long weekend coming up, so we can look forward to that. All right, feedback from that, as I said, Rachel's one was really, really good. Basically, the difference in the design is this little bit in here. And I think I really feel that they have put this in to test your ability of words that are very close together. The difference between two words that are very close together. So this is a dynamo. And we know it's a dynamo because the LED, which is a diode, only lights in one direction. So if I spin this in the opposite direction, or if I change the magnet direction, the diode only lights in one direction, and diodes only work in one direction. So this is a dynamo, and it has split rings. So this is the commutator arrangement here, and I don't know if you can just about see those. Those are the little brushes there, and every half turn, it changes the side of the coil which is connected to each side of the diode circuit, the LED circuit, the output circuit. So every single half turn, the coil side changes side of the output circuit. So you get DC out. Now that is exactly as a DC motor is. So the output you get is this bottom one here. So that is using slip rings, that's a dynamo. Now in a alternator, I apologize, so see what I said, they're very close words together. That is using split rings, that's a dynamo. Now in a generator, it's not a split ring, it's two slip rings. And as the thing turns, then the side of the coil stays in contact with the same side of the output circuit. So the coil is going up through the field, down through the field, up through the field, down through the field, alternately. And so you get an AC output, which looks like this one here. So it's going positive, negative, positive, negative, positive, negative output. Now, that is the key difference between an alternator, produces AC, very easy to remember that, and a dynamo produces DC. So I asked then, if you've got a dynamo output like this and you want to smooth it, so in other words, you want it to be closer to a battery output. Now batteries have outputs that look like this, that are pretty constant. So you want to actually smooth this out to stop it being on, off, on, off, on, off, on, off 50 times a second. We need to think about this equation here, which is the decay equation of a capacitor. So what they actually do is they put the, and I think I mentioned that, they use capacitors in parallel with the generator. They put a capacitor in parallel with the generator, and the capacitor charges and discharges, charge, discharge, charge, discharge, charge, discharge, like this. And so you get roughly kind of smoothed output like this. Okay, and it looks something more like what you have for a battery. Now that's a really, really important idea, and they like to ask you difficult questions. But how do you make sure it's really smooth? Well, it's all about the decay the way that capacitors actually discharge, they discharge exponentially. So this is voltage and this is time. For a discharging capacitor, it looks something like this. So if it were to discharge almost completely in the one time period of this DC, then you wouldn't get a very smooth circuit. It would just go down here, down here, down here, and you'd still be pretty bumpy. So what they have to do is keep the time constant, which is 1 over RC, keep RC as large as possible. So big resistors or big capacitors, basically, big R's or big C's, mean that it discharges more slowly. So a big RC would discharge something more like this, and so that it would remain at that higher voltage for longer, meaning you get the more smoothed output. So that is some tricky questions they could ask you about some pretty straightforward stuff at first. The idea of generating electricity simply by moving a magnet relative to a coil of wire. All right, I really hope that helps. So I'll have a quick look in the chat. Really nice comment there. Yeah, my pleasure doing these. I'm not going to give up on this idea of daily physics revision questions. It's just that I know I can't do it tomorrow, and I figure I might as well just leave it till the Tuesday after the half term. It's getting pretty real now, isn't it? It's getting pretty close, and I know that the real exams, I've just put all the dates in my own diary. The real exams are pretty darn close now, aren't they? So I think the first one, is it 22nd of May is your first GCSE Physics exam? So I'm thinking about what I can do to help people best prepare for those. So I'm not going anywhere. I'm just coming back with a different idea the week after, and I might then come back to this daily, or I might think about quickfire, or I might do something where I find out what your priorities are and help you with those things. So it's not that I'm going anywhere. It's not that I'm not going to do this. I've really enjoyed this and found this really, really useful. There are 10 now in the playlist, which is all in the description. Go back if you haven't seen them all. Go back to the first one. Still leave comment. Still have a go at answering them. All of those things. I've really enjoyed doing them, as I said. But I think I'm just going to sort of have a pause. I have something else that I really want to get finished for you all in the next kind of week. I'm thinking, am I going to get it finished? I had hoped to have it finished like a month or so ago, but it's just finding the time to do all these things. So watch this space. Next week I'm coming back with another idea. So no, I'm not going to tell you, because if I tell you and I don't do it, Rachel, then I'll feel bad. So I hope it'll be useful anyway. And I've got another idea for next week. But if you guys have ideas of what you think I can do, how you think I can help you, then please do ask. There are loads of videos in the meanwhile to help you. This is Guerrilla Physics, and we've got some of the best, I think, the best tips and strategies for studying physics. And I think I've got some of the hardest kind of videos and the highest level explanations of the most difficult topics to help you get the grade 9s or get the A stars. So look in the description for the kind of recommended playlist. Make sure you've been through all those. And happy revising for now. At the minute, one of my kind of tips for you is to stay really, not relaxed, but stay really calm and work hard on topics that you find the hardest. Identify areas that you need to work on and work on those. Make sure you're also covering the basics, and you're learning your definitions, and you're learning your equations and all of those things as well. And as I say, look into my playlists and think what you think are the hardest bits and what you think you need to do. Rachel asks, what would I rate as the hardest topics? I have a video of that, hardest topics in GCSE Physics. I've done a whole kind of bunch of that. I don't know if you want me just to, it will take a little while to read through them. But if you find, there is a video, Guerrilla Physics, hardest topics in GCSE. Those are the things that I think are the hardest topics. It's not like overall topics. I think the hardest kind of overall topic is either mechanics or electricity. So it's either motion or electricity in GCSE. But I picked out all the little tiny bits from those that I think are the really hard kind of concepts they can ask you. We use AC motors in windmills as well, right? Not in windmills. In wind turbines, they have AC generators, and generators. Well, if we say generators, we tend to mean alternators, because we generate electricity, put it into the national grid, and that needs to be alternating current. So we tend to mean alternators. We tend to mean an AC generator if we just say generators. Whereas if we know we need to make DC, then we use dynamo. Thanks, Rach. Yeah, I thought you might have watched that one already, but that's the kind of areas. If you go through that kind of list and have a little sort of tick off, make sure you can do all those bits. Probably be pretty good. All right then, dudes. I'm going to say ta-ra for now. Have a lovely long weekend. Have a nice, relaxed, calm bit of revision coming up. Okay, don't overdo it. Make sure you get your rest time as well. Work smart, not